We have an Excel file working well. We have tested this on Greedo, and Greedo gave us a shell. And we can move from there to run some of the attack commands as well as make it persistent as well. I will discuss about some limitations today again. We have tested some of those actions in our development environment, but some of those will be tested live as well, and you will face some of new challenges. Excel file needs to run dropper, and dropper needs to call MC patcher, and it needs to run the patek implant, and patek implant should start communications with patek service, which is great. However, we have a limitation. Let's talk about this. Patek service is currently running, and Greedo can double-click the Excel file back again, as he wants allowed the macro to run. The macro will run next time automatically without any challenge or anything to change. This one is the new implant ID. So we have this implant ID and we have some commands. If we remember the UAC bypass, we were able to use STCLT, and that was stored under Windows System 32. Let's run a command to see that whether or not it is there. It's not there. The file is not found. This is the very same system. The user is Greedo, so what's happening? It is actually a sandbox restriction of the Excel. So whenever a macro runs, Windows Defender starts monitoring it, as well as Excel restricts some of the behaviors. That's why we need to think a bit different. And our manual actions must operate differently as well. First of all, what we can do is quite important. We know what we can't do. For example, calling it directly, it doesn't work. And SDCLT is important for us to get the UAC bypass. If we try the other methods such as injections and etc., they will also trigger MC and some other alerts here as well, because MC is currently monitoring also the macro environment, even though we patch some of those process memory and MC scan buffer. There are some other controls still monitoring us. So let's escape from this restricted environment. What we can do here is, first, what paths are available for us? Let's see. And our application data path is still there, and it is still writable. If so, we can upload our batch file as UBP bat there, just like our UAC bypass. So it is there. Let's verify that it is properly uploaded or not. Let's get the file information. It is there, which is great for us. And we need to add this to the registry, right, for the UAC bypass. But this time, we have a challenge. The challenge is the SDCLT is not accessible by us. So we have another way to do that. This one is quite simple, but also noisy. We need to find a way to be persistent. TA505 during the campaigns have used the registry run key, which means hey current user, software Microsoft Windows current version run will have a new key that triggers the malware to run for the next time. The batch file we have uploaded here is a simple PowerShell command, if you remember. It deploys a dropper, so the chain starts back again. But this time it starts with dropper, not the Excel file. That means we will just leave the Excel restrictions behind. However, it comes with a catch. Registry key is added. However, we have two limitations here, and they all related to the time. We need to wait for it. Or we can force the user to log off. Force is not a great way, and you will see why shortly. And I'm giving a log off command while the implant is running here. So it didn't go well. Let's try again. It's standalone. There is no binary for it. So log off will not work always. But this may work during the domain environment. So what we need to do here is just wait. We have an implant, but the user will get bored or complete working, and user will log out eventually. The user signed out, and our implant is disconnected. Now we need to wait for a new implant, right? If user comes back, our persistency settings, which means the registry key we used, will trigger, and we will receive a new implant. That's the assumption. The system is here, and we are just waiting for it. But if you remember Windows, for each restart or start, it does run some of the commands or some of the tools already to complete this startup process. Some of those may not have network settings, some of those may not have authentications, and etc. But as you see, the run key has started working automatically, and we receive the shell. We have saved this as Windows Defender Update Service and under run. This run key is highly monitored, but it makes sense to use it in this context because TA505 has used it. We can use WMI, event registrations and subscriptions, or compromising the Excel or Word documents normal dots, normal templates, or we can add additional persistencies as well, as this is too obvious. But it still works, and let's move there and let's see how it works in our real environment. Now the screen is here, and let's run some of the commands back again. User, who am I? Brief. It is here, but it does not pop up any window anymore because it is unrelated and it is running in a different context. Though we still have the same challenge. The privilege level is still low to us. So we need to change this perspective again. We have uploaded our file UBP under a certain path that we can reach out back again. Let's verify that it is there or not. It is still there because our persistency is based on it. Let's complete our UAC bypass. Our UAC bypass is simply adding another registry key for our batch file and delegating execution through registry again, and hopefully running SDCLT that will give us this option. Now we have a new implant. Before jumping to this new implant, I will show you the difference between. First of all, we can understand our integrity level using additional tools or concepts. I will introduce a new tool in our next video or next videos. It is seatbelt. It is developed by SpectroX red team engineers. And simply we will use seatbelt, and I will talk about seatbelt and its features shortly. But let's run seatbelt with basic OS info to understand our current integrity level. It simply runs and prints out its logo and then gives you the basic OS enumeration now. And it says that the process is currently in medium integrity, and the user is local admin, so UAC bypass is possible. That's what we exactly did, right? The new one, which is this one, should have a better integrity. Exec whoami priv will show a lot of privileges. And if we run this command back again, which is executing a sharp assembly through a file command, our local file is seatbelt executable, and basic OS info is here. And when we run this time we are local admin, and the process is in high integrity. That means we elevated our privileges using the UAC bypass, and no Windows Defender alerts have been triggered. Previous alerts were there for a reason, because we were also testing different types of environments. But this time, we didn't receive any stop or any alerts. This one is, for example, coming from one of the tryouts as well, the previous ones. And I don't know what is VAC attack, but probably because of the PowerShell integration, or maybe loading assemblies will trigger similarities in Windows Defender. I don't believe PATAC has its own signature in Windows Defender yet. But while we are doing this, Windows Defender is on, cloud delivery is on, automatic submissions are on. So eventually this UAC bypass or MC bypass or PATAC itself will be signatured. So eventually they will be not available to everyone. So you need to modify them. And in our next video and the videos, we will talk about what we can do with this current compromised Greedo user.